Okay, in part 2 of the graphing techniques lesson, we start talking about symmetry. So we start this part of the lesson by studying symmetry. What we mean by symmetry. If we have a function f of x and we multiply the variable by a negative sign, I mean we change the sign of the variable, and graph the function, we obtain the same function. Or if we substitute negative x in the function, that will not affect the function, we still get the same function. This is called symmetry with respect to y-axis. So here x becomes negative x and we still have the same y. And if we have, this is the first thing. The second thing, if we have those are equivalent, if we multiply the function by negative sign, we still have the same function. The function will not be affected. So this is called symmetry with respect to x-axis, the x-axis. So here y becomes negative y, and that will not affect the graph. I mean, we still have we have symmetry in this case. So the symmetry with respect to y, we change the sign of x and we still have, and we get the same function, and that means changing the sign of the variable will not change the value of the function. So let's take an example. If f of x equals x squared plus 4, and I asked you to determine whether there is a symmetry with respect to x or symmetry with respect to y. So let's start with symmetry with respect to y. With respect to y, so that means we need to change the variable, the sign of the variable, into negative. So f of negative x is, now we substitute here negative x squared plus 4, but negative x squared is the same as x squared because negative sign with the power, even power, that will give me a positive, plus 4, but this is nothing but the original function. So f of negative x give me f of x, and that means we have symmetry with respect to y. Let's see if there's symmetry with respect to x-axis. So in this case, we just multiply the function by negative sign, and we see if we got the original function, that means we have symmetry about the x-axis. So we multiply the original function by negative sign, we get negative times x squared plus 4, and that's negative x squared minus 4. That's not equal to the original function f of x equals x squared plus 4. That means no, we don't have symmetry with respect to x-axis. And actually, by the way, the graph of this function looks like this. As we can see, we have symmetry about the y-axis, but we don't have symmetry about the x-axis. Okay. Now let's take some examples, other examples. if y, let me use x here, x equals y squared minus 3. Let's study the symmetry with respect to y-axis. That means we change the sign of the variable x. So we change the sign of the variable x. This becomes negative x equals y squared minus 3. I mean x becomes negative x here, but this is not equivalent to x equals y squared minus 3 because x is not equal to negative x. So here, no, we don't have symmetry with respect to y-axis. What about symmetry with respect to the x-axis? In this case, we change y into negative y, or f of x into negative f of x. But here we just have y, we don't have, it's not written as f of x. So let's substitute negative f of x for f of x, or negative y for y, because we have y. So this gives us x equals negative y squared minus 3, and that is x equals y squared, positive y squared minus 3. But this is equivalent to the original equation. That means yes, we have symmetry about the x-axis. And actually, if we graph this function, the graph looks like this. As we can see, there is symmetry about the x-axis, but we don't have symmetry about the y-axis. Let's take another example. X squared plus y squared equals 16. So first we study the symmetry about, or with respect to, the x-axis. Symmetry with respect to x-axis, that means we change y to negative y. So this becomes x squared plus negative y squared equals 16. But this is x squared. Negative y squared is just y squared because negative here and the power is even. That means we obtain positive value equals 16, and that's the original equation. So yes, we have symmetry about the x-axis. What about the symmetry with respect to y-axis? In this case, we change x into negative x. So this becomes negative x squared plus y squared equals 16. But negative x squared is just x squared plus y squared equals 16. This is the original function, original equation. Sorry. So since this is the original equation, that means yes, we have symmetry with respect to y-axis. And actually, if we look at this function or this equation, sorry, this is not a function, this is just an equation or relation. The graph looks like this. This is a circle that has with the origin 0, 0 and radius 4. So 4, negative 4, 4, negative 4. So the graph looks like this. It's a circle with radius 4, and as we can see, this is symmetric about the x-axis, and this is symmetric about y-axis. Okay, now the last example here in this part is the following equation: 2x plus y equals 4. We want first to study the symmetry with respect to x-axis. In this case, we change y into negative y, so we have 2x plus negative y equals 4, and that's 2x plus minus is minus y equals 4. This is not equivalent to the original equation, so the answer is no here. What about symmetry with respect to y-axis? In this case, we change x to negative x, so we have 2 times negative x plus y equals 4. 2 times negative x, negative 2x plus y equals 4. This is not equivalent to the original equation, so the answer here is no as well. So this is neither symmetric about the x-axis nor symmetric about the y-axis. The graph of this function looks like this, and as we can see, we don't have any symmetry about x-axis or y-axis. Now the next concept is the even and odd functions. Even and odd functions. So we say that the function f of x, f is even function if f of negative x equals f of x. This is closely related to what we discussed in the symmetry part. So if we substitute negative x, we get the same function. That means the function is symmetric, the graph is symmetric with respect to the y-axis. And it's odd, the function is odd if f of negative x gives us negative f of x, and that means it's symmetric with respect to the origin. Let's take an example. So we want to determine whether each of the following, or each function defined below, is even or odd or neither. So let's start with the first function. The first function is f of x equals 8x to the 4th minus 3x squared plus 1. Now for this function, let's apply this rule. If the function, let's see if is it even. If f of negative x equals f of x, then it's even. So let's substitute negative x. We get here 8 times negative x to the 4th minus 3 times negative x squared plus 1. But if we have even power, we still have positive value. So it's 8x to the 4th minus 3, this is x squared plus 1. But this is the original function f of x. So yes, it's even. Is it odd? If we want to check if it's odd, so f of negative x is negative f of x. If this is satisfied, then it's odd. So let's substitute negative x. 8 times negative x to the 4th minus 3 times negative x squared plus 1. This is 8x to the 4th minus 3x squared plus 1. What about the right hand side? We just multiply the function of x by a negative sign with negative 8x to the 4th plus 3x squared minus 1, and those are clearly not equal to each other, so this is not odd function. Now if the function has only even exponents appear on x, then it is always even. So let me write it here. If the function has only even exponents appear on x, then it's always even. Similarly, if the function has only odd exponents appear on x, then it's always odd. As we can see from the previous example, look at the powers here. All powers over x are even, 2 and 4, then this is even function. Okay, so let's take another example. F of x equals 6x cubed minus 9x. Is this even or odd? Look at the powers. This power is 3 and this power is 1. Those are odd powers. Or exponents. That means the function is odd. And actually we can we can use the rule. The rule says f of negative x is negative f of x. So let's substitute negative. 6 times negative x cubed minus 9 times negative x. Now negative x cubed is negative x, so times 6 is negative 6x cubed. Now negative 9 times negative x is positive 9x. As we can see, this is the left hand side. What about the right hand side? We just multiply the original function by negative sign. We get negative 6x cubed plus 9x, and actually those are equal to each other. That means the function is odd. Let's take another example. If we have a function f of x equals 3x squared plus 5x, is this even function or odd function? Let's start even, checking if this is even. If f of negative x equals f of x, then it's even. So let's substitute negative x. 3 times negative x squared plus 5 times negative x. The power is even, that means we get x squared, even and squared. That means negative x squared is positive x squared. 5 times negative x is negative 5x. What about the right hand side? The right hand side is the original function, 3x squared plus 5x. Those are not equal because of the negative sign here. It's different from the positive, so not even. Let's see if it's odd. If it's odd, then f of negative x is negative f of x. So substituting negative x, we already did that here. So we got 3x squared minus 5x. What about the right hand side? We just multiply the function by negative sign, and as we can see, those are not equal because the sign here is positive, the sign here is negative. So the answer here is no. This function neither odd nor even. Okay, now the last thing here, and that's the most important thing, is the transformations. What do we mean by transformations? In most of the cases, when we have functions, we have functions that, the basic functions that are modified. I mean, we may have some expression or constant added to the basic function, or subtracted from it, or added to the variable of that basic function, or subtracted from that variable, and that's what we call transformation. Sometimes we have some constant multiplied by function, and so on. So let's talk about first vertical transformation. In this case, the function g consists of the original function, the basic function f, plus or minus some constant c. And we have two cases. If c is greater than 0, then f of x plus c is translation upward. If c is also greater than 0 and we have f of x minus c, that means we have translation downward. For example, f of or g of x equals x squared plus 1. X squared is the original function. This is the basic function. And we have 1 added to this. So if we add some constant, positive constant, if we add positive, that means we have translation upward. So if we graph this function, the original function x squared, this is x squared, and if we want to graph x squared plus 1, we shift this function up by 1 unit. So this is 1, this is x squared plus 1. If we subtract, then we have shift 1 unit down. So this is x squared minus 1. So this is the effect of adding or subtracting from the function, adding some constant or subtracting a constant from the function. Now this is a vertical translation or transformation. Now we have horizontal transformation or translation. Let's use translation here. So horizontal translation, that means g of x is the original function, the basic function, but we have some constant added or subtracted from the variable x. So in this case, if c is greater than 0, then if g of x is f of x plus c, if we add some constant to some positive constant to the variable, then we have shift to the left. If we subtract constant from that variable, then we have a shift to the right. So for example, if we have g of x equals x minus 1 squared, as we can see here, we subtracted 1 from the variable x. We didn't subtract it from the whole function as we had from the previous example. In the previous example, we added or subtracted from the basic function, but here we are subtracting from the variable. If we subtract from the variable, we have this case. So we have to make a shift to the right by 1 unit. So the graph, this is the basic function x squared, and then x minus 1 all squared. That means we make shift to the right. If this is negative, we make shift to the right. If it's positive, we make shift to the left. So shift to the right by 1 step. The graph looks like this. This is x minus 1 squared. So the graph has shifted to the right. So we have horizontal translation 1 unit to the right. Let's take another example. If we have let's take g of x equals absolute value of x plus 2. The basic function is the absolute value function. This is absolute value of x. This is the basic function. Now we added some constant. We added 2. That means here, if we add some positive constant to the variable of the function, to the variable, that means we make shift to the left. If we add, we make shift to the left. So how many units? 2 units. So if we determine 3 points, for example, this is 2 2, this is 0 0, and this is negative 2 and 2. So we make shift to the left 2 units. The effect of this will be on x, because we are adding to x. That means we make shift to the left. So we make shift to these points to the left. 2 steps. This point becomes here. It becomes, if we subtract 2 from the x coordinate, we get 0 2. This point becomes here negative 2 0. This point becomes here negative 4 2, because we subtract 2 from negative 2. So the graph looks like this. This is absolute value of x plus 2. We have shift to the left. So we can summarize this. If c is greater than 0 and y equals f of x, the original function or the basic function, plus if we add some constant to the original function, we have shift by c units up. And if we subtract c from that function, some constant from that function, we have shift by c units down. If we add to the variable, as we can see here, we added to c to x, then we have shift by c units left. If we subtract from the variable, we have shift to the right. Okay, let's take another example, or the last example in this video. If we have this function f of x equals negative 1/2 x squared plus 4, and we want to graph this function. Now we ask ourselves, what is the basic function? The basic function is x squared. So let's graph x squared here. This is the graph of x squared. And then we multiply it by negative 1/2. What does that mean? Let me determine 3 points: 0 0, 1 1, negative 1 1. And then we multiply by negative 1/2. That means we multiply the y coordinate by negative 1/2, because we multiply the whole function, the whole basic function, by some constant. That means we multiply the y coordinate by that constant. So this will give us, if we multiply this by negative 1/2, we get 1 negative 1/2, and 0 0. We multiply this by negative 1/2 and get this point here, negative 1 negative 1/2. If we graph this function, we get this graph. So it's reflection about the x-axis. And then we add 4. So this is negative 1/2 x squared. Now we want to add 4. So if we want to add 4 to this function, to negative 1/2 x squared, that means we add some constant c to the function. If we add some constant to the function, that means we shift the function c units by c units up. So we have 4 units here, so 1 2 3 4, that means here this is 4. Now what happens to this point here? So we need to determine some points on the graph. So let's use 0 0. This point here is 1 negative 1/2, and this point here is negative 1 negative 1/2. Now we add 4 to each y coordinate. So if we add 4 to this, we get 1 and negative 1/2 plus 4, that is negative 1 plus 8 over 2, and that is 7 over 2, which equals 3.5. So this point becomes here. So 1 and 3.5, or we can write it as 7/2. And here negative 1/2 will give me same thing here. So negative 1, 3.5. So the graph looks like this. This is the resulting graph. So this is the graph of f of x equals negative 1/2 x squared plus 4. So the most important thing here is that we determine the basic function, we plot or determine 3 or 5 points, and then we make the changes on these points. So if we want to show you again what happened here, this is the original function x squared, and we determine 3 points, 0 0, for example 1 1 and negative 1 1. This is x squared, and then we multiply by negative 1/2. So that means we multiply the y coordinate by negative 1/2. This point here becomes 1 and negative 1/2, and this point stays 0 0. This point negative 1 becomes negative 1 and negative 1/2. So this is the graph of negative 1/2 x squared. We have reflection about the x axis. And then the last step is to, after determining these points, we need to add 4. We need to add 4. So add 4, that means we make a shift up by 4 units. So we add 4 to the y coordinates of these points. So this point is 1, this is negative 1, this is 0. So if we add 4 to this point 1 negative 1/2, I mean to add 4 to the y coordinate, we get 3.5. So this is 1 and 3.5, and negative 1 gives negative 1, 3.5. 0 gives 4, because we add 4 to the y coordinate. So we get this graph. So this function is negative 1/2 x squared